So first we need to look at we need to find out the distribution of states, and that is basically to get the concept of macrostates and microstates. So distribution of states is nothing but we need to find out, we want to find out, excuse me, how particles are distributed in different energy states. We'll take two examples, and those two examples will give you clear idea what you mean by distribution of states in quantum system, and that will propagate to classical system for statistical thermodynamics for biological molecules. Now we'll take the example 1. So in example 1, we'll be basically looking at distribution of 4 indistinguishable particles who are distributed in 2 energy states. Let's write it down. So we are looking at distribution of 4 particles in 2 energy states. So let's say energy states are epsilon 1 and epsilon 2. So here I'll be using epsilon for the energy, and for the total energy I'll be using capital E. So epsilon 1 and epsilon 2 are basically the energy of state 1 and state 2. Now I said that we have 4 particles. So how can you distribute 4 particles in these 2 energy states? So one distribution is I put all 4 particles here. I can make another distribution where I can put 3 particles here, 1 particle here. I can have another distribution where I put 2 particles here and 2 particles up there. I can have another distribution where I put 1 particle here, 3 particle up there, and putting all 4 particles in the E2 state. So how many distributions you got? So you got 5 such distribution, and these 5 are called the macrostates. So for 4 particle systems with 2 energy states, we can have 5 macrostates. Now let's look at this particular macrostate, which we name as 2,2, which defines that 2 particles are in epsilon 1 state and 2 particles in the epsilon 2 state. So if now the particles, are distinguishable, So by the term distinguishable, I mean that these 4 particles, they differ from each other and you can distinguish them. And so those 4 particles are, let's say, P, Q, R and S. In this case, they are all same. So here my particles are distinguishable. So if these 4 particles are distinguishable, for this 2,2 macrostate, how many different distributions we can have? So let's look at it. So we have epsilon 1, epsilon 2, and we have 2 up there, PQ up there, and we have RS down here, because we have 2, we are basically looking at this particular macrostate. So we can have PQ up, RS down, we can have PR up, QS down, we can have PS up and QR down. So we have 3 state. We also can have RSPQ. We also can have QSPR, and we also can have QRPS. Do you have any other possibility? I don't think so. So what you basically see here, that for a 2,2 macrostate, we have 6 different distributions, and these 6 are called the microstates. Okay. So for our 2,2 macrostate, we have 6 microstates. So likewise for other macrostate, you can have different number of microstates as you can find it out in your leisure. Now let's look at the second example, and the second example was 5-particle system. Let's go back and see. So the example 2 was we want to see the distribution of 4 indistinguishable particles. So here we have a restriction. The restriction is the total energy should fulfill as 5 epsilon. So again, you are talking about 4-particle system, but we are looking at the total energy 5e. So we let's say we have different energy states. So you have energy state, the ground state 0e, 1e, we have 2 epsilon, okay, epsilon not e, 3 epsilon, 4 epsilon, 5 epsilon. These are the different energy states, and we have 4 particles, and we have total energy 5e. So that we have to keep that in mind. So I can have 1 particle here, I can have 3 particles here. So this is it's a 4-particle system, so it does not fulfill. So if I have 4 particles, so this total energy is 3e. So therefore, this is not the right distribution. So what will be the distribution? So we can have 2 particles here, 1 particle here, 1 particle here. So what is the total energy now? So we have 2 cross 2, 4 plus 1, 5e. So this is the right macrostate. Now let's look at other possibilities. So I'm just extending this. And we'll be basically counting how many macrostates we have for this particular system of 4 indistinguishable particles with total energy 5e. Now, we can have another distribution where we have 1 particle here and all 3 here, right? So that also sums up to 5 epsilon. We can have 1 particle here at 4e, 1 at 1e, and 2 in ground state. So that is also total 5e. So we can also have, we have 3 plus 2, yeah, no, we can have 1 here, we can have 1 here, and we have 2 there. What are the other possibilities do you have? So we can also have 3 plus 1. We can also have 3 particles. We did not, 3 here, 1 here. So that's 3 plus 2, 5. Do you have any more way? Do you have any more ways to distribute? Let's look at it. There should be one more. 1 plus 4 is done. 1 plus 4 is done. 3 plus 2 is also done. 4 plus 1, 3 plus 2, 5 plus 0 is also done. Let me look at my note. There should be one more. With 3, 1 is over. 3 here, 1 there, 2, 1 to 1 is there, 1. Okay, so we can have one more where we have here 2 there, yes, and 3, right. So do you have any more possibility? No. So these are the 6 macrostates you get for this 4 particle systems with total energy 5 epsilon. Now we name this distribution as no, let's say let's look at this particular distribution, which we name as 1 3 0 distribution, and we look at this particular distribution, which we name as 2 1 1. So why 2 1 1? Because we have 2 particles in this state, we have 1 particle in this state, you have 1 particle in this state, and this is 1 3 0, we have 1 particle in this state, 3 here, 0 here. So now the question is, what will be the number of microstates in 2 1 1 and 1 3 0 macrostates. Number of microstates in these 2 macrostates we want to find out. So again, so for that we say that particles are distinguishable. So now the particles are again distinguishable, and they are P, Q, R, S. So let's look at for 1 3 0 distribution how many microstates we can have. So we have 1 3 and 0 microstate, and so we have energy state 0E, 1E and 2E. So we have P, we have QRS, we have Q, we have PRS, we have R, we have PQS, we have S and PQR. So these are the four different microstates. Do you have any other microstates for this macrostate 1 through 0? I guess no. So this particular macrostate is having 4 microstate. Now let's look at the other distribution we took as 2 1 1. Yes, we took as 2 1 1. So what will be the distribution for this particular macrostate? So we can have PQ RS, we have PRQS, we have PS QR, and then we have QR PS, we have QSPR. We also have RSPQ. Do you have other states? Yes. So these are 6 microstates. We can also have 6 more. So basically we have PQ, SR. They are still 2, 1, 1 microstates. We have PR, SQ. We have PSRQ. We have QRSP. We have QSRP. We have RSQP. So all of them are signifying that 2, 1, 1 distribution. So for this 2, 1, 1 macrostate, we got total 12 microstates, right? Okay, so now let's so we have seen the distribution of states.